In this video, I'd like to explore what point-slope form of a linear equation is and how we can use this form to then write equations of lines. So here we see the point-slope form of a linear equation. We notice that it is y minus y1 equals m times parentheses x minus x1. Now there's some variables here we've seen before. First of all, we have our normal variables y and x. We also notice that we have our value m, and we remember that m is the slope of the line, which is our rise over a run. The new thing about this certain form is that we actually see two other values, x1 and y1, and these are actually the point x1, y1. So the good news is that if we have this slope and the point of a line, we can simply plug in these values, m, x1, and y1 and y1 being again from the point on the line, and we can then actually get the equation of a line just by simply plugging in these values. So this means that we can write a line very quickly as long as we have these two things. So let's practice a couple examples of writing equations in point-slope form. Now here we see our first example. I'm given a slope of 3/4 and it goes to the point 3, 4, and we are asked to write an equation of the line that goes through the point 3, 4 with this given slope. So first, I'm just going to write out our slope point form. So y minus y1 equals m times x minus x1 is our point slope form that we just learned. And I'm simply going to plug in our values, remembering that this 0.34 is really just x1, y1, and then similarly our slope over here, this whole 3/4, is really just our m value. So if we plug this in, I start with the value y minus our y1 value, and our y1 value is simply 4, equal to our slope, which if I look at our given values, our slope is right here, 3/4, so I can plug in 3/4. Then parentheses, our variable x, minus, and now I'm just looking for the x1 value from our point, which is 3, so plugging this in, I get x minus 3, and then very simply, this is our slope form equation right here. So, second equation, slope is negative 2/3, going through the point negative 1, 5. So again, we can remind ourselves, well, this slope, negative 2/3, is our m value. And this point here is our x1 and our y1. So if I write out our point slope form of the equation, y minus y1 equals m times parentheses x minus x1. All I need to do now is plug in our key values. So our y1 value, I can see right over here, is the value 5. So I'm going to write y minus 5. Y minus 5 equals, now our slope I can see is this m value of negative 2/3. So I'm going to write negative 2/3 times parentheses x minus, and here a little bit different, our x value is a negative 1. So I actually notice that I'm going to be subtracting a negative 1. And just as a reminder, when we subtract a negative, what we're really doing, right here with this minus of a negative 1, is we're actually adding a 1. So subtracting a negative, this really turns to a positive. So to rewrite our equation in its final simplified form, we really have y minus 5 equals negative 2/3 parentheses x plus 1. And that would be our simplified point slope form of the equation right here. In this third problem, we're given the slope of 6/5 and the point of negative 7, negative 6, and we're again asked to write the equation of the line that's going to have this slope and intercept the following point. So what we notice is that we can simply write, again, our slope form equation, y minus y1 equals m times x minus x1. And again, we note that the slope is our m value, so we can label the 6/5 as our m. And we remember that the point -7, -6 represents our x1 and our y1 values. So if we insert these values in, I have y minus our y1 value, which we see over here is -6. Now I want to be careful plugging in that minus a -6. I'm going to put the -6 in parentheses, and I'm really remembering that a negative and a negative, or in other words, subtracting a negative, is really adding. Then I can see that the m value here is 6/5 times x minus, and again we have to be careful, I'm subtracting a -7, so when I subtract that negative, this really turns into addition as well. So that means our final form is going to be y plus 6 equals 6/5 times x plus 7. And that'd be our final form of our slope-intercept form, slope point form equation. So now a little bit more of a difficult example. I'm given 2 points that I want the line to intersect, 1, 3, and 3, 6. And we might be thinking, well, I have more than enough points. I have 2 points, but I don't have the slope. But remember, we can actually find the slope, or in other words, the m value of an equation from 2 points. We can remember that the slope is really m equal to rise over run. Rise over run. Or in other words, the rise is the difference of our y values, so y2 minus y1. And then the run is really the difference of our x values, or x2 minus x1. And before we set this up and plug in our equation, I can remember that right over here, this point 1, 3 is really x1 and y1, and this point 3, 6 can really be x2 and our y2. So we can find our slope m by simply plugging in these values. So that looks to me like our y2 is 6 minus our y1, which is 3, over our x2, which is 3, minus our x1, which is 1. Or in other words, we're going to get a slope, or an m value, of 3 over 2. Now from this point, once we have our new m value, our new slope, all we have to do is just plug in again to our slope point form of an equation. So if I write that out again, our slope point form is y minus y1 equal to m times, in parentheses, x minus x1. So now all we have to do is just plug in our values. Now, it has y1 and y1 in the equation, but I can technically use x2 or y2 just as easily. But we might as well use our y1 value. So if we look back at our point, our y1 I can see right here is 3. So I'm going to say y minus 3 equals to our slope m. And if we go back up here, I notice that our slope that we found was 3 over 2. So I can plug in that slope that we found, 3 over 2, times, in parentheses, x minus, I just need to find the x1 value, which I can see right here is 1. So then plugging that in, we can finish off our equation with x minus 1. And then there we have it. A little bit of extra work to find our slope, but then we can still write this slope point form of an equation right here. So as another example, we can again label our 2 points here as x1, y1. So -4 I can call x1, -2 I can call y1, 0 I can call x2, and -3 I can call y2. And we remember that this is enough for us to find our slope, since the slope, or in other words the m value, is just equal to rise, or in other words the difference of the y values, y2 minus y1, over the run, the difference of the x values, x2 minus x1. And if we set this up, this is simply equal to, for plugging in, -3, that's our y2, minus our y1 value, which is a -2. And remember that double negative really means I'm really adding 2, all over our x2 value, which is 0, minus our x1, which is a -4, which of course means I'm really adding 4. So it looks like if we simplify this, negative 3 plus 2, that looks to me like a negative 1 on the top, and then 0 plus 4 on the bottom. It looks like our slope is negative 1/4. So now all we have to do is just plug in our equation, and it looks like we have enough room right over here to do that. So if I write out our slope point form, that's y minus y1 equals m times parentheses x minus x1. I can simply plug in our values. So y minus, I can see from the points given that our y1 was negative 2. In other words, y minus a negative 2 equals, our m value that we found was right here, negative 1/4. So I can plug this in, giving us negative 1/4 times in parentheses x minus, and if we look at our x1, it looks like a negative 4, so I'm really subtracting a negative 4, which means I'm really adding 4. And just like here, subtracting negative 2 means I'm really adding 2. So writing out our final form then, we can simply say that our point slope form is y plus 2 equals a negative 1/4 times x plus 4. And that would be our final point slope form of this equation. So one final example, we're again given 2 points. I'm going to start by finding the slope, the m value. And remember that m is equal to our change in the rise, or y2 minus y1, over our run, which is our change in the x values, x2 minus x1. So to plug these in, we can simply label the points that were given. I call the 2 negative 4. I can call x1 y1. And the 7 1 I can call x2 y2. So plugging this in, y2 minus y1, that looks like our y2 is 1 minus a negative 4, or in other words, looks like we're doing 1 plus 4 for our rise, over, for x2, 7 minus 2. And 1 plus 4 and 7 minus 2 both come out to be just 5 over 5, or in other words, it looks like our slope value is simply 1. So now all we have to do is plug into our slope point form equation. Y minus y1 equals m times x minus x1. So if we now plug in the values we were given, our y1 value here is a negative 4. So if I subtract a negative 4, we realize that we're really doing y plus 4 equals, the slope we found was 1 times x minus our x1 value, which is a 2. And so there we have it, our slope point form of an equation that goes through the points 2, negative 4, and 7, 1. So at this point, I have a few problems I'd like you to try on your own. So give those a try, and we'll check in on these and other problems on graphing equations from points and slopes next class.